What I'd like to do today is go over some of the critical parts of the Datamite USB 3 and Datamite Mini hardware. And first thing I'd like to explain is when we do movie files, we have to set the computer at a very low resolution. This is a 600 by 800 display. The reason we do that is makes the movies take up a whole lot less memory, and it makes the recording a little faster and such. So anyway, so what you see on this screen, on your actual computer screen, will probably be much bigger, much better resolution, and much faster reacting, because when the software has to run and we have to record at the same time, it does take a lot of computer power. And so anyway, just wanted to explain that. So when you first get your Datamite system from us, you're going to be getting a big user's manual, and inside the user's manual there's going to be a quick start guide. A piece of paper says quick start. This one happens to be for a dyno. And here it lists some of the most critical things to get you up and running fast. Inside this piece of paper is going to be some folded up other sheets of paper that describes your particular sensors, your particular options. That is the stuff that is the most important for you to read. The book has information, detailed information about making graphs, making reports, overlay graphs, preference settings, all stuff that's good to read eventually. But I know you want to get up and running as soon as possible, and pay attention to this quick start guide. So I'm only going to touch on a couple parts of the software now, and then we're going to get to the hardware. But in the software, a very critical thing for you to understand is this software over the years has been developed for lots of different data loggers. For you to have the software work with your particular data logger, you got to start with a data file that was for your particular data log. And the Quick Start talks about this. And the way you do that, because we have a Datamite 3, it's a silver box, you click on File, Open from All Saved Tests, and for the Datamite 3, this is a good example file. Example folders is where we hold these example files, is a good one for you to start with, or is the only one for you to start with. If you have a mini USB, you would start with this example. We have the silver box, the Datamite 3. We're going to start with this box here. You just highlight it, little preview shown here, and we're going to open it. Then what you do, because we're dealing with hardware, we're going to go right to the Datamite settings. Click on Datamite. A little thing, I won't get into this now, but it says they do match our master Datamite specs. Okay? Yours probably won't say that. But here we have some examples, are an example configuration for a Datamite. To get the Datamite to communicate, you can see here it says Datamite 3 USB. An important thing to figure out is what COM port is it talking on. This is a USB device, but it talks just like a COM port, a very high-speed COM port. So what we provided is a find button here to find what looks like available COM ports. And you can see here possible COM ports are 1, 4, and 13. Now if you had experience with any of your COM ports, you might know that 1 is being used for your fax machine or something. Typically, the highest number you see here is more than likely your COM port. But what you do is you try this, it didn't work, then you try that one. So anyway, it's just showing you what looks like it's available. So 13 is the highest one there. I'm going to change this to 13. And then I'm going to go and look at the current readings. Do you want to save these changes to yes? Yep, I'm going to save them as the master. I'm going to say yes. Here's the current reading screen. If I pick a correct USB device, you see what it says checking COM port, it's going to come back and eventually say USB communications haven't been established. And you can see here we have a good way to tell you if you're making communication also. If you see numbers that are changing a little bit, like here the power volts. Power volts is very low because right now I'm only plugged into the USB cable. The USB cable does provide power. It's low power, like you can see, it's less than 5 volts, but it's enough for making a lot of the functions of the box work. But if you don't have a power supply plugged in, when this would pop up to like 12 to 16 volts, if you don't have a power supply plugged in, not every sensor could work. And so that's why we say plug your power supply in also. But for this demo, this is fine. And we have 16 boxes here showing our channels. And we have 2 sets of those 16 boxes. This is the standard analog channels, and I'm going to go over here. We also have RPM and the internal thermocouple channels and accelerometers, which in a dynamometer is meaningless to you. And we have numbers shown here. We also have gauges and stuff up here, but these gauges require you to have set them up correctly under options. You see gauge settings, bar graph settings, exhaust, and all this stuff. Lots of adjustments you can make to everything up here, but the numbers you see down here are right and true, and this is what you should use for troubleshooting. This number can be exactly right, but if you didn't set those options up right, it will not show up correctly up here. So these are the numbers you want to look at down here to see what really is happening. Okay, here we have our Datamite 3, our silver box. You can see there's connections on this side, connections on this side. This is where most of your 0 to 5 volt and RPM channels are going to plug into on this side. Here are our 4 thermocouple channels, and this is typically vehicle power, dynamometer power, which is just a 12 volt wall transformer, and your USB connection. And you can see we got a light coming on here. That's showing we got power, and it is communicating. If you weren't getting communications, you wouldn't see that light come on. So we are communicating to the computer, which is a good sign. Okay. Now, these two, you can see them labeled up at the top. These two right here, I'm sorry, are your RPM inputs. These are frequency inputs. This happens to be your switch input. And then we have our analog inputs, these two 8-pin connectors here, analogs A and B. Now for RPM, we have a magnetic sensor, and we can have optical sensors also, but this is going to trigger off of a magnet like here. We have smaller ones also, and typically for a dynamometer installation, this is going to plug into RPM's B. If you're running a chassis dyno or a Briggs inertia dyno or something, you're probably going to want engine RPM also. And the way we typically get engine RPM is with inductive pickup, which cleans up the signal right off the spark plug wire, and you plug this into RPM's A. A lot of times this stuff will come from the factory, this stuff already installed like this, and then you just keep everything connected, take it out of the box and go. There is an adjustment screw on our inductive pickups, our newer inductive pickups, to set the sensitivity. And there is a quick piece of paper that describes all this stuff, how it works, what to be careful of. One thing you want to be careful of is this. A lot of people will over torque this and they'll split this aluminum body. So do not over torque this. Another trick is you might want to mount this in rubber. It helps isolate it from vibration, because if it's vibrating or if you smack it, it will false trigger. So that's something to be aware of there on the magnetic sensors. But we do have different types that are more expensive, and we have optical sensors also.